I'd like to talk to you about the scientific method. The scientific method is a logical sequence of steps in order to solve a problem or perhaps gain more information. Just like a math problem would be, following a logical sequence of steps, that's exactly how the scientific method is. It follows a logical sequence of steps, beginning with a problem and ending with finding out new information about something. So again, scientific method starts off with a problem. For our example, I chose to think about the effect of fertilizers on plants. So say you're kind of wondering, maybe if I use double the amount of fertilizer on a plant, then the plant will grow twice as big. I wonder if that will happen. I'm just wondering about that. It's kind of like a problem I'm thinking about. So the first thing you do once you have a problem that you've identified is you research the problem. And that's to see if anyone else has already answered this question. Maybe someone else has already found out how fertilizer affects plants. So get on the internet, look in some books, see if there's any research already done on the subject. So say for our example, with fertilizer on plants, no one's done any research. Okay, so we move on to the next step. The third step in the scientific method is to formulate a hypothesis. And a hypothesis is simply an educated guess. So we have spent some time researching and we didn't find out too much about the effect of doubling fertilizer on plants. So we found out that fertilizer is supposed to help plants. So I'm going to come up with a guess, an educated guess. They say fertilizer helps plants, so I'm going to say, well, if I double the amount of fertilizer, my plant should grow twice as big. So that's my hypothesis. If I double the fertilizer, my plant will grow twice as big. Kind of an educated guess, just wondering about it. So the next step is to perform an experiment. And that's the fun part. That's what science is all about. Getting your hands dirty, getting in there, figuring out, get what the problem effect is and gathering data and that type of thing. So, fourth step, perform an experiment. So, a word about experiments. Experiments, again, stay very organized and orderly so that we can duplicate the experiment. Sometimes scientists from around the world are interested in other scientists' work, so they can duplicate the experiment if everything is written down in an orderly fashion. So, here we have experiment, test the effect of one thing on another thing. And that's basically it. And in our example, we're going to test the effect of fertilizer on plants. So, we have an independent variable. An independent variable is changed to see its effect on a dependent variable. So in our case, with our plant fertilizer experiment, our independent variable is the fertilizer. So we're going to check to see how fertilizer affects plants. That's our independent variable. Dependent variable, changed by the independent variable. So again, since we are testing the amount of fertilizer on plants, the poor plants are the dependent variable. We're changing the amount of fertilizer to see its effect on the plants, so the plants are dependent upon the amount of fertilizer they do receive. So for our example, the independent variable would be the fertilizer, and the dependent variable will be the plants. So we set up our experiment and say we have double the amount of fertilizer and we're going to use it daily on the plants to see if the plants will grow twice as big over a certain period of time. So data, observe, we'll be watching our plants and see how they grow over a particular time period, maybe 7 days, say. Then we're going to gather and analyze our data, and we use a chart to do that, to stay organized. So I have a chart here, a T-chart, because of the way it's shaped. So my X would be the amount of days, maybe 1 day, first day, second day, third day. And then my other variable would be the effect on the plant. So I would have to measure plant growth. Is the plant growing at all? And I would measure that with a ruler, say, to see if the plant is getting bigger or not from the extra fertilizer. Then we are observing our plants, we're gathering our data. Lastly, after say 7 days, we decide to run this experiment. We're going to analyze our data. So analyzing data means looking for patterns in the data. Did the plants continue to grow larger and larger in organized way, in a predictable way? Did the plants die? Did the plants grow faster than stop? So again, look at our data and look for different patterns that happened along the way. So then write these patterns down. Very important to write everything down. Again, you want to be able to go back and look at what you did and see its effect. So this is the hard part, to look at the data, look for patterns, and then to organize in your mind enough what you see to actually write it down. But it's a good skill to have. Okay, then the last part of the scientific method is to write a conclusion to your experiment. So that would be reread your hypothesis. So we need to go all the way back to where we started in the video. My hypothesis was that plants will grow twice as big with double the amount of fertilizer. That was my educated guess, or my hypothesis. Next, compare my hypothesis with my data. So say my plants died. They did not like double the amount of fertilizer. They died. So if I compare my hypothesis, which was they'll grow twice as big, to my data, which is that they died, I would say that I did not prove my hypothesis or support my hypothesis very well. So again, think along these science lines, write this comparison down. Did I prove or disprove my hypothesis? I would say my hypothesis was the plants would grow twice as big. My data shows that the plants died. I did not prove my hypothesis because doubling the amount of fertilizer ended up killing the plants. So, scientific method.